Okay, so in this video we are going to look at question 5 of November 2016 question paper. This is a functions question with a parabola and hyperbole. Hyperbola and mostly grade, well, all of it still grade 11 type work, but obviously asked on a grade 12 level here. So it says, sketched below is the parabola f, there we go, with the equation fx is minus x squared plus 4x minus 3, and hyperbola g with the equation x minus by plus t is equal to 3. This is a bit weird, but they've obviously taken the standard form and just rearranged it a little bit to write it like this. We'll see what to do with that as we go along. And then B is the turning point of F lies at the point of intersection of the asymptotes of G. Oh, that's cool. Alright, so if I can find the coordinate of that turning point, it's going to give me both asymptotes as value of the other graph. That's quite cool. A minus 1, 0 is the x-intercept of the graph of G, the hyperbola. 5.1 show that the coordinates of B are 2, 1. Oh, and they actually help me what those coordinates should be. You have two ways of calculating the coordinates of a turning point for now. In differential calculus, we're going to learn a third way. I'm going to just show you both for the purpose of just exercising as well. So if my equation fx is equal to minus x squared plus 4x minus 3, the first way to get the equation of the coordinates of the turning point is you can just complete the square for this equation, because in completed square form it actually looks like that, and then PQ is the coordinates of the turning point. So for this, I can just complete the square. To complete the square, I start by taking out the negative. Then I'm left with x squared minus 4x plus 3. And then to complete the square, what I typically do, I'm just going to put this brackets, block brackets, because I'm going to create more brackets now. To complete the square, what I do is I take my b value, I half it, and then I square it into the bracket above again. So plus 4 minus 4, half the b value is negative 2, and then if I take negative 2 and square it, I get plus 4, and I take plus 4 minus 4. Then this trinomial, that's what I'm doing here, is I'm completing a trinomial to be a perfect square. So this trinomial should be my perfect square. Then the minus 4 plus 3, which is negative 1, is then the what's left there, and then I'm just going to multiply in the negative again into the big block brackets. So negative times that bracket is just negative that bracket, and negative times negative 1 is going to be plus 1. So from this I can see PQ, you see the PQ, which is the turning point B, is 2, 1. Can you see there? PQ 2, 1. The P has a negative in front it, so the P is just 2, right? And then the Q is 1. So that's the one method you can do, completing the square. The second method you can do is from this equation, you can take the PQ is still your turning point, right? So the P you can calculate by taking minus B over 2A, right? Some of you might recognize this. Let me just quickly turn to the information sheet. Minus b over 2a is that first part of the quadratic formula, actually, there, without the plus minus root 3. So I get my p value from that, and then the b is 4 here, so I have negative 4 over 2, and the a is negative 1. Negative 1, so negative 4 over negative 2 is obviously positive 2, and then to get the q value you can just substitute this p into the equation. Alright, so I'm going to take the function and substitute the p value in there, which is then minus 2 squared plus 4 times 2 minus 3, and you can check with your calculator, but you should get then 1. Okay, so then the turning point is 2, 1. right, the turning point B. This is just two methods of doing the same thing. You can just split them. So this is by completing the square, and this is by using minus B over 2A to get the P, substitute into the original equation to get the Q, and then that also produces the turning point. In grade 12, we also learn in differential calculus that you get a turning point, any turning point, by making the derivative 0 will give you the P value, the X value, and then if you substitute that into the equation, again you get the Q value. So you can also do that, making the derivative 0 later on. Okay, question 5.2, write down the range of f. Okay, so f is the parabola, the range, all of the possible y values. Since this parabola is going down into infinity, this parabola can be any y value, can have any y value that's smaller than or equal to, obviously, the value at the turning point, which is 1. So y can be smaller or equal to 1, which is the Q. Okay, any real number smaller than 1. Okay, then 5.3 asks for which values of x will gx be bigger or equal to 0. Bigger or equal to 0 is above the or cutting, since the equal is there, also the cutting point, but above the x-axis. So the graph of g is above the x-axis there, right? It's above, and then it's below, and then for that whole bit it's above again. Alright, so above the x-axis, because there's an asymptote above the x-axis, so all of this is going to be above the x-axis, and that is the point where x is 2, since that's the point 2, 1. Right, so this bit lies on the x-axis anywhere smaller than negative 1, smaller or equal. So x can be anything smaller or equal to negative 1. And then not between negative 1 and 2, the graph is below, and then after 2, anything after 2, but I can't include the 2 because there's an asymptote, the graph does not exist at 2, so x can be anything bigger than 2. Alright, so anything smaller than negative 1, anything bigger than 2 will produce values that's bigger than 0 on the graph of G. Question 5.4 says determine the equation of the vertical asymptote of the graph of H, which is a new graph, right? If H is given by gx plus 4. So the graph of H is a new graph. That's the graph of G, my hyperbole here. That's been moved 4 units to the left. Right, so this graph is currently at this asymptote. They actually want the equation of the vertical asymptote of the new graph. So the old graph has a vertical asymptote here at 2. If I move this graph 4 units to the left, the asymptote is going to move to negative 2. 2 minus 4 is negative 2. So x is negative 2. X is negative 2 is going to be the equation of the new asymptote. Right, question 5.5, determine the values of P and T, which is those missing values in my hyperbole. Okay, I think it's going to be easier to just first find the equation of the hyperbole on this sketch, just in straightforward standard form, and then try and rewrite that equation in this form to try and see what the values of P and T are. So let's do that first. Okay, the equation of hyperbole is normally y is equal to a over x minus p plus q, where the p and the q, the p is your vertical asymptote, which is in this question at 2, so I have that. The p is 2. The q is your horizontal asymptote, which is at 1 in this question. I have that. And I need the a. Maybe if I have any point on the graph that I can substitute to help me find the a. So minus 1, 0. So I also have the point minus 1, 0 that I can substitute. That's the information that I have. So let's substitute that. So I'm going to make the y 0. X is negative 1. The p is 2. And the q is 1. And now I'm trying to find the a. So this is, let's take, okay. Minus 1 over minus 2, minus 1 minus 2 is minus 3. So this is a over negative 3, but you can put the negative in front there as well, right? It doesn't really matter in a fraction if the negative is on top there or there. It's the same. It will produce the same result. So I'm just going to move the negative there, and then to make this positive, move it to the other side. So then I have a over 3 is 1, and then multiply by 3. So 1 times 3 is 3. So the a is 3. Right. So this equation looks like this. Y is equal to 3 over x minus 2 plus q, which is 1 plus 1. Okay, and I want to try and write it in this format to try and see what the p and the t is. Okay, so the first thing is I'm going to just take the 1 over there. So I have y minus 1 is equal to 3 over x minus 2. And then I'm going to multiply this fraction here on the other side as well. So then I have x minus 2 times y minus 1 is 3. And now this looks like that. You see, x minus p, y plus t is 3. Right, and I can clearly see that the p is 2 and the t is negative 1 because there's a plus t, right? So that means the p is 2 since there's x minus 2 and there's x minus p. The minus is there in both of them. The p is just 2, right? But here is y plus t. And there is y minus 1. So obviously this is plus negative 1 if I write it strictly the same. So the t is going to be negative 1. Determine the values of p and t. Done. Write down the values of x for which fx times gx is bigger or equal to 0. Right, now this pertains to something times something bigger than 0, meaning something times something that gives me a positive. Now I know a positive times a positive gives me a positive, and a negative times a negative gives me a positive, right? I want bigger than 0, which is positive, is the result that I want. So I want fx and gx to both be positive, bigger than 0 or above the x-axis at the same time, or I want them both to be negative, but I don't want one to be positive and one to be negative, right? So let's go find that on the sketch. There's my x-axis. I'm looking at above and below the x-axis, right? Okay, so if I move here, there's the graph of f. The graph of f is below the x-axis and the graph of g is above. Right, so here I have one above and one below. I'm trying to find both above or both below, right? So before there, I have the graph of f is completely below there at that stage. So f is below, g is above, that's not good. Then after that point, both of them is below. Right, so here is the first marker. Both of them is below, both of them is below, both of them is below the x-axis up until here, right? Where the one goes above and now the other one is below. So one is above, one is below. And then at this asymptote, both of them is above. So there's my next marker. I want from there to there, where both is below. Then no, one is above, one is below, and then from 2 again, there's my new marker. Both is above up until there, where the one goes below again. So from there to there, right? There both is negative from there to there, and then one is above, one is below, and then from 2 again, both is above, and then there this one stays above, but then that one goes below. So then from 2 from that point there the one is above and the one is below the x-axis. Okay, so I'm looking at from A to that x-intercept, and then from 2 to that x-intercept. I need the two x-intercepts of the parabola to have those values there. Anyways, okay, so I'm going to find the x-intercepts of the parabola. The parabola is minus x squared plus 4x minus 3. I'm going to make that equal to 0 and divide with a negative just to get it in standard form. Factors of 3 that I add to get 4 is simply 3 and 1. And these signs are the same, both negative, so x is 3 or x is 1. Right, those are the x-intercepts of the parabola. Is at, obviously I can see since this one is first, that's 1 and this is 3. Right, and my result that I want here lies between negative 1 and 1 and then between 2 and 3. So I want to write that down. So my answer for 5.6 is going to be x must lie between, and I'm going to make it equal as well, because they wanted the 0 points to be included. These are my 0 points, the minus 1, 1, 2, 3, those are my 0 points, so I'm going to include that, except for the asymptote, because the G does not have graph on the asymptote. I have a problem at the asymptote. You can never include asymptotes in your sets, right? So whenever G is involved, and it is, I cannot include the asymptote as part of a set. Okay, so between minus 1 and 1, minus 1 and 1, or x lies between 2 and 3, where I'm going to include everything, all of the 0 points, but I'm not including the 2 asymptote, right? This is set builder notation. You can also write it like this. So x is an element from negative 1 to 1, for those of you that prefer this, or then x goes from 2 to 3, where yet again you see I include all of the points with a block bracket, but I exclude the asymptote. Right, and this is question 5. I will see you in the next video for question 6.